Alright guys, welcome to another math tutorial video. The topic of this one being long division of polynomials. Now, the term long division I'm sure is a very intimidating idea and it probably doesn't conjure up the best memories from elementary school. But in truth, long division of polynomials is not significantly more difficult than long division of just whole numbers like you've been doing for many years now. Now, like I said, it does seem intimidating at first, but once you get the idea down, it's just as simple as synthetic division. My students, I see just as many of them using this method as I do see using synthetic division. So, in truth, they're not that horribly different. So let's go ahead and set up this problem. Just like a long division problem of your youth, we're going to put our divisor here on the outside of this division bar, and on the inside we'll put our dividend. At least I do believe that's what it's called. Oh, my elementary math terminology is not as sharp as it probably should be. Alright, so what we want to do, anytime we set up a long division of polynomials problem like this one here, our first objective is to make this first term, the first term of our divisor, x, match the first term of our dividend. In this case, our first term is x squared. So we would ask ourselves, how do we turn this number into that number, or this variable into that variable? Now the answer to that question, which I'm sure you've already come up with, is we just multiply it by an x, right? If we multiply this x by x, we get x squared. So once we come up with that number, that variable, whatever it is we multiply this first term by to make it match this first term, we write it right above here, right above this line. So we figured out that would be an x. So I'm just going to write an x up there. So now what we do, and this always is the one part that kind of trips students up when they're first learning how to do this, is we take both of these terms, the x and the positive 7, multiplied by the number we wrote up here, multiplied by this x. So we are going to go ahead and multiply x by x and get x squared, which we are going to write right below this, this polynomial right here, just like we did in long division. And then we're going to take this positive 7 and we are also going to multiply it by the x. We multiply both terms. So after this x squared, we are going to write 7x. Now we don't leave anything here. This is kind of like a 0. Our term just ends after this 7x. Now, yet again, just like long division, we subtract these two. Now x squared minus x squared is of course going to give us 0, right? But then we have 10x minus 7x. This is one area where I see more mistakes than any other. You have this positive 10x and then you have a plus 7x being part of this little quantity, this little equation right here. And students automatically want to go to 10x plus 7x, forgetting that this minus sign all the way out here applies to this whole subtraction problem. You always have to be mindful of that it is going to be 10x minus 7x. And that will give us 3x. Now, since there's nothing here, we just drop this down. It doesn't matter how many more terms are out to the side here. We just drop it straight down. So it's a positive 21. We're just going to write plus 21. Now what we want to do is the same process of before. We still want to make this first term of our divisor, this x, match the first term of our dividend, our new dividend, 3x. How do we do that? Of course, we just multiply x by 3, right? Multiplying x by 3 will give us 3x. Now it's a positive 3 in this case that we would have to multiply it by. So we write a positive 3 or a plus 3 right above this line. If we had to multiply it by a negative 3, it would be a minus 3. That's where we get the signs, is from the signs of our numbers. So we go ahead and multiply this 3 right here by both of these terms. 3 times x, 3x, 3 times 7, plus 21, right? Now here, this is a subtraction problem yet again. 3x minus 3x is 0, and then 21 minus 21, also 0. So this came out very cleanly, very perfectly, right? And we got the answer of x plus 3. Now this was a very simple one, just being x squared. We could have factored this pretty easily without having to do long division, but this was just a basic example that I wanted to show. Now not all problems are going to come out as cleanly as this one did. Let me move the camera here a little bit. As you can see, like we just did, this came out to zeros all the way across. This x plus 3 came out of it perfectly. Or this x plus 7 came out of it perfectly, I should say. They're not always going to be like that. Sometimes you are going to have a remainder, and you are going to have to find out how to deal with that. Sometimes you're going to have a number left all the way down here. And that's what we'll talk about in this next problem. So let me change my piece of paper here, and we will move on. Let's try out the problem. I'm going to go ahead and write it in the division bar kind of form, in the long division form. Let's say we have x to the third. You know what? Let's make that 4x to the third plus x squared minus 6x plus 5. Let's try that out. And then we will divide this by, oh, what sounds good? X plus 2. Let's try that. Divided by x plus 2. Why not? Okay. So our first thing we need to do, we need to make the first term of our divisor, x, match the first term of our dividend, in this case 4x cubed. Now there's a couple different things, or one main different thing about this problem than the one we had before, and that is this goes x to the third instead of just x to the second. So it adds in one extra layer, one extra step to this. The process isn't any more difficult or any more complex, not even any different, just one more step. So let's make this x match 4x cubed. The way we're going to have to do that, of course, we're going to have to multiply it by 4 for starters. And to turn a single x into x to the third, we're going to have to multiply it by x to the second. So the number we're looking for is 4x to the second, right? So we're going to multiply each of these terms by 4x to the second. We will get 4x to the third. And then 2 times 4x to the second will in fact give us 8x to the second. I'll draw a line, minus sign. These subtract out to be 0. And then we have x minus 8x, x squared minus 8x squared. So we are going to get negative 7x squared. Each of these two terms will drop down because there's nothing below them. So we'll get minus 6x plus 5. Now what we need to do, yet again, just like before, we need to make the first term of our divisor match the first term of our new dividend. So we're going to have to turn x into negative 7x squared. Now we got to keep that negative right there. Whenever we did this subtraction problem, it made a negative 7, so we are always going to have to keep that sign. So to turn x into negative 7x squared, we're going to have to multiply that by negative 7x. So we'll go ahead and write that right up there. So negative 7x times x, negative 7x squared. Negative 7x times 2, negative 14x. Yet again, we'll do our division problem. We'll subtract. Not division problem, our subtraction problem. This turns out to be 0. And then negative 6 minus negative 14. This, yet again, trips some students up. It's almost easier sometimes to write it off to the side a little bit, like negative 6x minus negative 14x, so that they can see we're subtracting a negative, right? So we're not actually subtracting, we're turning it into a plus sign. So we are going to actually be adding this 14 because we're minusing a negative. Or subtracting a negative. So negative 6 plus 14 is going to be 8x. Nothing's below that 5, so we'll drop it right down. Yet again, now for the last time on this problem, we have to make x match 8x. That's not too difficult. Just 8, right? Positive 8. So we'll multiply each of these terms by 8. We'll get 8x and then 8 times 2 is going to be 16. Subtract for the final time. This gets 0. And now, unlike before, we're not going to get a 0 here, right? We have 5 minus 16. We're going to get a negative 11. So, we can't make this term, just x, match a negative 11. We can't make it match a term that doesn't have a variable in it, right? So, unfortunately, this is our remainder. I'm sure you all remember remainders from school. So, we have to deal with this. Now, it's not difficult at all. One little thing to remember with it, and you've got it down. We have our answer up here, 4x squared minus 7x plus 8. And then we take this remainder, negative 11, and we drag it up here. Take whatever sign it was a negative 11, right? So we take that negative sign and we write minus after our last term. Then we write the number, 11, and we put just that number, just the 11 in this case, over our original divisor, x plus 2. So if it was x plus 2, like this case, that's what we write it over. If it was y minus 12, then we would write y minus 12 under it. Whatever our original divisor is, whatever that quantity right there is, we write under our remainder. So this is going to be our final answer. 4x squared minus 7x plus 8 minus 11 over x plus 2. So that's about it for long division of polynomials. It can go up higher than x to the third. It can be x to the 47th. You're just going to have more steps each time as you go through. One other thing I want to mention is if you ever come across a problem that's like you're dividing from x to the third plus x minus 7, where you're kind of missing that x to the second term, or whether you're missing x to the first term, whatever it is, you do need to account for that whenever you're writing out the problem. You would write, for example, with this, plus 0x squared, and then you would move on to that plus x minus 7, that kind of idea. So just like synthetic division, where we account for the missing terms, we do that in long division too. Just one note I wanted to make real quick. Otherwise, all the long division you do, whenever you're strictly taking out a quantity like this with a singular x and a constant, will be this method right here. If you have any questions, comments, or concerns about this video or anything about it, feel free to leave a comment below or visit my blog, mrmathclass.blogspot.com, for more information. Thanks a lot for watching, and I will see you all next time.